Welcome to this explainer. Today, we are taking a sledgehammer to a really common assumption, the idea that complex problems always require complex solutions. We live in an era that is completely obsessed with big data, massive algorithms, and these incredibly intricate forecasting models. We just naturally assume that to crack a tough problem, we need a really complicated tool. But, as we're going to see, the data from across finance, medicine, and risk management is telling us a completely different story.
It sounds totally backward, right? I mean, how could knowing less possibly make you more accurate? But today we're going to unravel the mystery of deliberate ignorance. We'll see how consciously ignoring certain data might just save your investment portfolio or, honestly, even your life. We're going to dig into how giving an algorithm or even a human expert too much information can actually trigger catastrophic failures when you're operating in an unpredictable environment.
You see, we all have this deeply ingrained psychological bias. We naturally equate complexity with accuracy. We just assume that a spreadsheet with 1,000 variables has to be smarter than a simple 3-rule checklist, right? But the high-stakes reality is the exact opposite. Out in the real world, in dynamic, constantly shifting environments, simplicity is actually what generates robustness.
Section 1. The Fidelity Paradox. Let's look at why massive models that can flawlessly solve something like protein folding often fail miserably in clinical prognosis and financial forecasting.
Here is the crux of the issue. In unpredictable fields, the real challenge isn't fitting the data, it's knowing exactly what to ignore. When you use a super high-capacity model like a massive neural network, it is so powerful that it's going to find a pattern no matter what. If you feed it noisy, unstable data, it literally memorizes the noise. It fits the data way too well, creating this incredibly fragile illusion of accuracy that just completely shatters the second it hits the real world.
A recent study on breast cancer diagnosis perfectly nails this paradox. Researchers took data from the UCI machine learning repository and pitted complex machine learning techniques against really simple linear models. The result? Absolutely wild. A basic logistic regression model achieved a staggering 97.28% accuracy, and it did this in just 35.56 milliseconds. It completely wiped the floor with complex decision trees and support vector machines. Because it was simple, it was transparent, proving that in life-or-death medical domains, a straightforward model is vastly superior to a complex black box.
Section 2. The Illusion of Complexity. So, let's shift gears over to finance and risk management to understand why smart people frequently get trapped by this illusion. Part of the blame falls on something called the Diderot effect. Now, this is named after an 18th century philosopher who bought a fancy new dressing gown and then suddenly felt compelled to upgrade literally everything else he owned to match it. Well, this dynamic perfectly describes financial modeling. One elaborate adjustment prompts another and another. Before you know it, you have a model so tightly wound that a single tiny assumption change blows the whole thing up. This massive, unseen systematic error blinds decision-makers, which leads directly to hubris-driven disasters like the infamous long-term capital management collapse back in the late 90s.
And this cycle right here perfectly captures the escalation of commitment heuristic. It shows how human psychology locks leaders into these losing, overly complex courses of action. You invest heavily in a complex system, it starts failing and throwing off negative feedback. But instead of just cutting your losses, the sunk costs drive you to pour even more resources in, desperately hoping to turn it around. We see this everywhere: corporate projects, algorithmic trading, even national wars.
Section 3. High stakes, simple rules. Okay, so if complex models are actually super fragile, what's our game plan? Let's deconstruct the myth a bit more by looking at how simple, rule-based heuristics consistently beat sophisticated optimization. Enter the take the best heuristic. This is basically an architectural and cognitive shortcut. It's an inference strategy where you search for cues in order of their historical validity, and you stop the absolute second you find one that discriminates between your options. You deliberately ignore the rest of the information. By exploiting this using what are called fast and frugal trees, professionals like airport customs officers or ER doctors evaluating chest pain can make incredibly accurate, lightning-fast decisions using just a tiny handful of data points.
And we see the exact same principle dominating in financial risk management. In the iris analysis on portfolio insurance strategies, researchers compared a very simple constant proportion strategy, or CPPI, against these highly complex, constantly shifting models. The basic CPPI strategy, which literally just uses a fixed, constant multiplier, holds its own against the complex dynamic models. It provides incredibly competitive equity market participation without sacrificing your downside protection. It proves, yet again,
that a rock-solid, straightforward rule often matches or outright beats an intricate, constantly adjusting algorithm.
Section 4. Shifting versus stable regimes. So, the big question. When should you trust a simple rule versus a massive AI model? Well, it all comes down to understanding the environment you're operating in.
Think about what happens when you introduce extra capacity in a shifting regime, like medicine or finance. In a shifting regime, the rules of the game are constantly changing, and you're usually dealing with data poverty. If you deploy a high-capacity model here, it plunges you straight into a dangerous fragility zone, where the model is just fitting real-world noise perfectly. To stay safe, you absolutely have to stay in the compression zone. You have to deliberately restrict the model's complexity so it only catches the most robust underlying signals.
It's fascinating because in unstable, shifting environments, piling on more features actually collapses your robustness. The more data you feed the model, the worse it performs out in the wild because it starts learning all these spurious fake correlations. Now, this is a complete contrast to stable regimes, things like chess, protein folding, or weather forecasting. In those stable environments, the fundamental rules never change, so complexity thrives and having extra data is a massive advantage.
Section 5. Epistemic compression. This brings us to a major reconstructive paradigm shift. It's a totally new mental model for designing solutions in an unpredictable world. And it's your ultimate defense against the fidelity paradox.
We call this epistemic compression. Basically, think of it as Occam's razor functioning as a hard-coded algorithm. It's not just about pruning data after the fact. It's a structural fence built into the very architecture of your decision-making. It forces a model, or a human team for that matter, into a state of deliberate ignorance, so it simply cannot overfit to shifting data. You are making it architecturally costly to represent variance that exceeds your actual, solid evidence.
The evidence backing this up from a massive metasynthesis is just phenomenal. Researchers analyzed 15 different high-stakes domains. They found that whether you're calculating ICU severity, assessing credit risk, or doing macroeconomic forecasting, restricting complexity is empirically superior when the rules are constantly changing. In these shifting regimes, simple models won a staggering 80% of the time. Those human experts who stubbornly refuse to add hundreds of variables to their clinical scores, they aren't being old-fashioned. They are acting as brilliant information-theoretic sieves, filtering out the garbage.
I really want to lead you with this powerful takeaway from the source material. It's a real mic drop. It emphasizes that true intelligence requires the absolute discipline to ignore patterns. In a world completely drowning in data, your greatest asset isn't your ability to process every single variable. Your greatest asset is your structural ability to filter, to compress, and to aggressively ignore the noise. So as you go about your day, I want you to consider your own decision-making processes. Ask yourself, are you falling victim to the fidelity paradox? Are you overcomplicating your investments, your business strategies, or even your daily routines? Try building an epistemic firewall around your choices. Embrace simple, fast, and frugal rules, and discover how a little deliberate ignorance can actually be your ultimate competitive advantage. Thanks for joining me on this explainer, and keep questioning the complex.